Hello everybody, welcome back to another edition of the EcoStruxure Machine Expert HVAC. I'm your host, Leandro Mada, and in this video what we're going to see is how we can use the inputs and outputs of our controller. So let's go to the presentation. So the idea is to have an overview, how the different inputs and outputs, how to use them on the software. So it's just a quick introduction, probably with a lot of information. So we have already seen that when we create the project in the EcoStruxure Machine Expert HVAC, we have different tabs. But if we want to use the inputs and outputs of our controller in the project, the first thing that we need to do is to give them names or a symbol to each of the inputs that we have. So depending on the PLC that we have, if we're using M172 or M171 optimized, we have different views on how to access to the data. In this particular part of the training, I'm going to focus only on this one, in the I/O mapping for local. Okay. Then, depending on the controller, we have field and we have extended and remote. These two are more related to additional I/Os and also for one specific display that can be used with the M171 optimized, and the field are more related to the expansion model that we have for the PLC, but that will be covered later. So what we're going to focus on this video is how to use the local I/Os that we have on the controller. So the first thing that we need to know is that depending on the controller, we have different amount of I/Os. Okay, and that is something important that we need to check. So please make sure when you are selecting the controller, go to the instruction sheet or the catalog to see the real amount of I/Os that it has, so you don't get confused about it. Okay, so now once we enter into local, the view is going to be different depending on the controller. Okay, so because it will depend on the amount of I/Os of each controller it has. So as soon as we enter into local, we can see that we have in the first column the name, which is the actual input and output that we have on the controller, on the embedded controller. And then we have the type, so that will give you the idea of the variable type, if it's going to be analog or it's going to be digital. And then the description, so you really know which is the input or output of the variable that you're going to use. Okay, now as you can see here in the column variable, we have an empty space. So the idea is for us to define a symbol that's going to be linked to the physical I/O. So we just need to give the name over here. Now, as soon as we define the name, as you can see, one example. Okay, for example, this analog input are going to be for temperature, this one just for the status of the filter, and this one to run the fan. And this one is analog output just to send the command of the speed for a drive for a motor. So you define the names depending on your projects. Once you have done that, you just need to compile. So the idea of compile this information is for us to easily see the variable that we have created or named for the digital or analog I/Os to be used on the programming part. So as soon as we compile this, if we go to the programming tab, you can see by default we have these three options or three main options. And then as soon as we compile, we can see this one, configuration variables. And we should be able to see a new element called I/O mapping, and inside all the variables that we have created before. Then we just drag and drop into our code, okay? And we can use them. So simple as that. So depending on the language that we are using inside the software, you have additional things to do. For example, if you're just using a structured text, you just drag and drop the variable and it's ready to use. If you're using, for example, this FBD, function block diagram, then you will need to define if the variable is going to be input or output. Okay, and if I hide myself a little bit, you can see here, if I drag this over here and I select input, you can see that it's pointing to this side, this input for another block. And if it's output, for example, this one is like it's coming from inside. So it's going the other way. It's going to be receiving the data. Okay. Just change the view how you can interconnect two function blocks. So now, before doing this, let's try to replicate this part of the software so you know that I'm not lying to you. So we just need to go to configuration. In the configuration part, you have the IO mapping. We just have local. So for example, I'm going to use this one as a temperature 01, and this one, let's say, digital input, I don't know, emergency, and digital output for QX alarm. Okay, and analog output, let's say this one or this one, analog output. Q output, analog, speed, whatever, doesn't matter. So if you go to programming, I haven't compiled yet. You can see here that I don't have the IO. This one, configure variables, is because I didn't delete what I have done in the previous video, but it should be appear here as an IO. So if I compile this part or compile all, so compile this, should be able to see in the output some results about the compilation. In my case, I have 0 warning, 0 errors, and I don't know if you can barely see it, but we just need to go to programming. And now in the programming, we have the IO mapping, and we just directly, we can use them. So, for example, alarm is going to be equal when not the emergency. You can type it, okay, or what you can do is to drag and drop this part. Let me see. No, I'm going to explain that later. The smart completing of the text, I'm going to show you later. But for example, this was in the structure, so just drag and drop. If you're using, for example, ladder, new program, ladder, okay, assign. Just drag and drop the variables. Okay, alarm here, emergency here. Okay, and you can negate this part, and that's it. So simple. Now, if you're using, now the additional thing is that if you're using the FBD, time, okay, it will depend on the input and output that you're trying to use, because you cannot write on the input, so you need to make sure about that. So temperature, input, okay, and now, for example, speed, output, and there we go. Then in the middle you have, I don't know, depending on the value, you just have a different set point. It's up to you using the PAD and then have the calculation, but this is what you need to do. Now let's delete this part. So delete program, delete this part also. So what we have done so far is to create some names for the inputs and outputs, so we can easily see on our code the variables. Now let's go back to the presentation. This is one good question. Is it possible to monitor the inputs and outputs without assigning names? Yes, it's totally fine. Let me just hide myself a little bit. So on the library tree, okay, in the software, we have on the project libraries target variables, and inside we have analog inputs, analog output, digital inputs, digital output, so we can easily see them when we are connected into the controller. So let's just have a look on this. So let's go to library, target variables, and here you have the different IOs. So we're going to cover that later, but you have also the expansion models. It will change depending on the controller, but you have the local IOs. So if it's expansion, you have an expansion. If it's local, in the embedded PLC. Now, if we connect to the controller, okay, I'm going to connect to this controller that I have over here. Yes, it's connecting. There we go. So if I put this part, you can see here on the bottom that is connected. I'm going to download this code. Yes, just to show you. Yes, doesn't matter in this case. I'm going to spray that later. Yes. Okay, good. So source okay, application okay. We're gonna cover that later. But so I am online mode. So one thing that you can do is to add this to the watch, so you can see what's going on. So I'm going to open the watch. Oops. And library 3 all together. So local analog input. You can see that I believe in this case I have a PT1000 connected. So if I touch this, you see that it's increasing the temperature. Okay. So now you have analog outputs. In my case, I haven't assigned anything over here. You have digital inputs and digital inputs. You can put it over here. And digital outputs you have, but in this case I haven't activated anything, so you aren't going to see anything yet. But this is how you can check the IO. So instead of programming everything, you just have it in there. There's also another way to see this. Once you are connected on the commissioning part, you're able to see, depending on the controller, you should be able to connect. Yes. And then here in IO values, you can connect and see what's really going on. But that is a different way to test this. Okay. So let's go back to the presentation. Good. So here is where we enter into more details. So I already explained to you how to assign names to the digital inputs and outputs. Now let's go to talk about a little bit of the different types of inputs and outputs that we have. Let's start with the first one for the digital ones, that are the more simple. So digital input, we only have two states. That is 0 false or 1 true. Okay, so if there is no voltage in there, you have 0. And if you have the 24-volt DC, you have 1, the true. That can change a little bit when you are using the analog input as a digital input, but that will be another story. We're going to focus only on the ones digital inputs and output that the PLC has already embedded. So this is the simplest thing to start with. It's just true or false. Okay, and we saw on the program, this program over here quickly that I show you. When I create the ladder, it's just new program, ladder, just drag and drop the variables. Okay, you can see over here I have one Boolean variable, alarm. They have 2 states, and that's it. Okay, so very simple, no major problem. What you need to check is the different commands that they may have. So it's always good to check on the instruction sheet of each of the controllers, so you can see if they have the same command or not. Now that we have already talked about the digital inputs, it's easy. Let's go for the analog inputs of the controller. So depending on the controller that we have, we may have different types. For example, if we are working with the M171, this one, the optimized, depending on the inputs that you have, you may have different types of analog input that you may use. So even if you can configure the analog inputs, it's important to know that probably not all of them can be used for the same purpose. For example, here in this M171, the first two, if I'm not wrong, okay, this one and this one, can be used digital input, NTC, or PT1000. Now, this one, the analog output number 3, okay, can be used for more things. So you need to be careful here and check always on the instruction sheet or the hardware manual of the equipment. For the M172 is a different story. We have all these types, okay, available for all the analog input that we have on the controller, but the configuration needs to be done by pair. So if you configure the analog input 1 as a NTC, then the other one must be the same type. But the analog input 3, it can be voltage, and this one should be voltage. So it's always by pair, okay? Now, how to configure this part? Because now that I see the presentation, see, okay, this is how it can be done. So in order to configure the inputs and outputs, as I showed you before, we have the BIOS parameters, and in the BIOS parameters, we are able to configure this by default. So going back here, just delete this one. Yes, configuration, BIOS parameter. Here, in this case, it's an M172 program, so you can really see this easily. You can modify and make the change that you want. Okay. Now, on the M171, so now if I open the application M171, that is on the other side here. So we just need to go to the same BIOS parameters, and here you can see the different things. You can see this one has more. This one to go back to the first two. So here is where you can change the type, and it's always recommended, at least for me, to do it before the download. Okay. So let's go back to the presentation. So now is the interesting things here. So we have the analog inputs and outputs. Now it's important to know the ranges for this and how we can work with the variables. So if you're going to read, if we configure the inputs and output, the inputs of the M172 as a voltage or current, it's important to know the limits. So by default, we have these two limits, from 0 to 1000. So it means that the values that you put on the input, for example, if it's voltage, 0 volt is going to be 0, and if you are using 10 volts, it's going to be the value 1000. And based on that, you can scale the variable that you have to make it work as you want it. The same can be applied for the analog input configured as a current, because your 0 amps, okay, 0 milliamps would be the value 0, and the 1000 is going to be the 20 milliamps. Now, you have a different behavior when you use it as a 4 milliamps to 20 milliamps, because the value 0 will give you the value 0 on the PLC will give you will be the 4 milliamps. And if we disconnect the sensor, the current sensor, it will give you the value minus 32768, and it's the same value when you disconnect the temperature probe. So for the temperature, if you're using, for example, let me see what I have used here. Let's go back just to show you, because I'm using a probe here. PT1000, I guess, or NTC, I don't remember. So training, so let's connect. So I'm reading this, see there is loading. Let's see the configuration. Lower, it's configured as NTC. So let's see this on the watch. You can see here I have the watch over here, so I'm going to try to disconnect the analog input, which I believe is the input, this one. So you can see you have the value minus 32,768. So I'm going to try to put this back again. There we go, you have the temperature back. So that is what I want to show you. In that case was the NTC, so if you disconnect you have that value that came from the one that you have by default. So let's go back. This part I believe I've already covered. What you need to know is the limits go from 0 to 1000. Now for the outputs, again we have different behaviors. So for the M171 optimized, we have I believe you have difference, I don't remember right now, I need to check the manual, but I believe all of them are current or voltage. Check that on the hardware, but you have the possibility to configure one of those, okay, one of the analog outputs, and the way that you need to use it is a little bit different, so make sure that you take a look on the hardware manual for this. Now for the analog output of the M172, you have current modulation, current on off, voltage modulation, and PWM. What I'm going to cover here is the current modulation and voltage modulation. So the current modulation is for 4 milliamps to 20 milliamps, and the voltage modulation is from 0 to 10 volts. Okay, so that's something that you need to know. And this is the table for the value. So if you, the output, so the analog output on the controller will go from 0 to 1000 again. So as soon as you enter the value 0, on the output you will have the 0 volts or the 4 milliamps. Now if you use the value 1000, you're gonna get the 20 milliamps or the 10 volts, depending on the configuration. So now that we know this, let's go to the application. So what I have done so far, let me just show you the controller. In the top part, what I have done is to use the analog output number 2 and I link it to the analog input number 8. So I'm going to play with the configuration of the analog output number 2 and see the result in the analog input number 8, just to show you what we got. So let's go to the application of the 172. And I'm going to create the logic because now we cover something different. What I'm going to show you is going to change the type of the analog input and output, and then I'm going to show you the value that I get. So this is the analog output number 1. Let's digital output number 2. Okay, as you can see, it's in percentage, is from 0 to 100%, but to give you the idea, the value is 0 to 1000. So something important. Now analog input number 8. Number 8, yes. So calibration, lower analog input here. So let's read the analog output, how it's configured. It's current modulation, and these two are configured as 4 to 20 milliamps. Okay, so what I'm going to do now is to send this to the controller just in case. So let's send a new value for the analog output. Current modulation. So here, so let's say that I have 100. That's going to be the 1000. The value is 1000. Even if you see the dot, the value is. So now I'm going to send this value, right? Analog input. So maybe here the cable is sent right. Let me just check this. Okay, I figured out that the cable wasn't connected properly. So if you take a look now, it's connected. This cable is connected from the analog output 2 to the analog input 8. And as you can see over here on the screen here, is I'm sending the value 100%. That's going to be 1000. Okay, and I get on the other side almost the 20 milliamps. So if I move here, the value is 0. Okay, you can see they have the value 0. Okay, that's going to be the 4 milliamps. If I, for example, 10%, it's going to be 100. You can see they have this value over here. Okay, so different story would be if I use, for example, the 20 milliamps. If I use the here the value, if it's configured as 0 to 20 milliamps, okay, you can see the value has been changed. Okay, let me just change this again so you can see it, because we are sending different information. So remember the number 2278. As I change this, you have different value because I'm sending, even if I send the same voltage, the same current, the impedance is different and the calibration is different. So that's why you get a different number. So here you need to make sure that when you change this, okay, you don't have anything connected because the impedance is going to change on the analog input. So in this case, I'm testing this because I'm testing this, so there is no problem. But in real life, I recommend you to don't have anything connected and make the changes that you need. So now what I'm going to do is to use the voltage. So I'm going to use voltage modulation. As you can see here, you are seeing the 100, which is the 10% of 10% of the 10 volts. It's going to be 1 volt. So if I got the multimeter, so we have the multimeter now. Okay, we should be able to see this value. So let's grab this. So I'm going to use this graph over here and use the analog input. So you can see that I have 1 volt. Oops, I touched 1 volt. So if let's go back here and go to the upper, change this to, I don't know, 10%, let's say it's 25%. Write this value to have 2.5 volts. Okay, so that's basically the idea. And if I use the 100%, that's going to be 1000. to get the templates. Okay. So as you can see, it's easy once you know. So we have already opened the program, assigned the IOs, compile program, change the variables, configure analogs, and change the type of the commission type. So we have already covered all of the things that I wanted to show you for the inputs and outputs on the controller. So remember to assign the names for the symbols that you want for each of the IOs. And also, if you're using the analogs, inputs and outputs, configure the right type that you want for them. Okay, so thank you very much for watching this video, and I see you on the next one.